everyone, and welcome to this video going over lesson 24-2, adding polynomials. In the last video, we discussed what a polynomial is, and now we're going to talk about how do we add two polynomials or three polynomials together. So the key thing is, all we have to do to add polynomials is combine like terms. We've combined like terms before. Remember, I recommend drawing different shapes around your like terms so that we can identify what our like terms are. So for instance, I have x and 2x, and then my numbers I have -2 and 5. X plus 2x is 3x, and -2 plus 5 is +3. Let's try this again. And keep in mind, in order to have like terms, the exponents for all the variables need to be the same. So even though we have 2y to the power of 5 and 3y, because the 3y has a power of 2, it is not the same as y to the power of 5. So 2 times y to the power of 5 is its own term. 3y is its own term. For numbers, I have 6 and -4, and 3y to the power of 2 is also its own term. I'll make that a rectangle. So, writing in standard form, I start with my biggest exponent, so 2y to the power of 5. Then I will do the 3y to the power of 2 plus the 3y, and then 6 plus -4 will be +2. So if there are no like terms to combine, we just leave the term alone, and make sure that when you write your answers, your polynomials are written in standard form, which means each degree, each exponent, is in order from biggest to smallest. Let's do number 3. I have 2x squared and -x squared. Those are like terms. I also have 3x and -4x, and 9 and -6. So 2x squared and -x squared just makes 1x squared. 3x and -4x makes a -x. And 9 minus 6 gets me +3. One more. For my numbers, I have 5 and 4. For my x's, I have -3x and +2x. And then for my x squareds, I have a single x squared and a -3x squared. So I have to start with the x squareds because they have the biggest exponent. X squared plus -3x squared is -2x squared. Then I have -3x plus 2x, which if I combine those, I get -x. And 5 and -4 combined gives me a +1. Polynomials can also be added using algebra tiles, which means we can use different shaped tiles to represent our like terms, and then count how many of the tiles of each like term we have the same. So for our first polynomial, 3x squared minus 3x minus 5, I have 3x squared blocks for my 3x squared. I have 3 -x blocks to represent my -3x, and 5 -1 boxes for my -5. And then I have the polynomial 2x squared plus 5x plus 3. So I have 2x squared blocks. I then have 5 x boxes and 3 1 boxes. Together, I have 1, 2, 3, 4, 5 x squared boxes. For every -x, I can cross off one positive x. So crossing off, crossing off, crossing off, crossing off, crossing off, crossing off, which means I'm left with 2x. And for every negative one, I can cross off a positive one. So negative 1, positive 1, negative 1, positive 1, negative 1, positive 1. And I'm left with 2 negative 1s, which means negative 2. And that is a more visual way of combining our like terms. So let's try this. It says, draw the algebra tiles to represent 3x squared minus 3x minus 5 plus 2x squared plus 5x plus 3. I will use different colors to show the different algebra tiles. So I'll start with my x squareds. I need to have 3 of those. 3x squareds for my first polynomial. And then I need to do 2x squareds for my second polynomial. I will use blue for my x terms. I need to have 3 negative x boxes for my first polynomial. And 5 positive x boxes for my second polynomial. And I will use purple for my numbers. I need to have 5 negative 1 boxes for my first polynomial and 3 positive 1 boxes for my second polynomial. So the solution I find by combining all my boxes together. I have 1, 2, 3, 4, 5 x squared boxes. Remember, every negative x can cross off a positive x. So I'm going to cross off my pairs until I'm left with only 2 x's, and they're positive, so this will be written as plus 2x. And then for every negative 1 box, I can cross off a positive 1 box until I'm left with 2 negative 1 boxes. So I will write that as minus 2. And that is how we add polynomials together. We are simply combining like terms, and we're going to see how subtracting polynomials is very similar to this adding polynomials process. Please let me know if you have any questions, and I will see you in class.